Hello YouTube, I'm Jay and today we'll be discussing part 2 of my filtration basics. So let's get started. So in a previous part, I discussed how the source of your pollution in the water is actually the food and not the fish, and you need a filter to process this pollutant into something that is harmless so your fish don't die. So what actually is in the food that ends up killing your fish? So basically, there are two components that need to be filtered out of your water. The first thing is these large particles that are visible to your eye that you need to filter. And the second component are tiny molecular level toxins that are dissolved in the water so you cannot see. And those are the two things that you need to filter out. And the large stuff, these non-dissolved solids, you need mechanical filtration. For these dissolved solids, not dissolved solid, dissolved toxins, you need biological and chemical filtration to get rid of. So what are these things? What is mechanical and what is biological and chemical filtration? So let's start off with mechanical filtration. So mechanical filtration, basically you're getting rid of the large particles. So there are several things that you can use for mechanical filtration. You can use stuff like sponges, or you can use stuff like filter floss, to name a few. So anything with small pores, like the sponge here, it's got tiny holes in it that can filter out the solids in your water while letting the water through. This is the most commonly used mechanical filtration. It's filter floss. It's pretty much the same stuff that fills your pillows. So this stuff is commonly used, and you can really use anything like this piece of cloth here. Anything with small pores like this that can let the water through while preventing the solids from going through, you can use as mechanical filtration. So initially, if your water is full of solids, once it passes through this layer of mechanical filtration, there won't be solids anymore. So you'll just be left with the dissolved toxins. So how you layer mechanical filtration is a concept that a lot of people seem to confuse. So I'll be discussing that here. So basically, in your water, you're going to have solids in a variety of different sizes. So you're going to have some large ones, you're going to have some medium ones, and you're going to have small ones. So basically, you want to have several different layers of mechanical filtration to account for that. So the ideal way to do that is go from coarse to medium to fine. That is the way you want to layer that. And I see a lot of people confuse this. The reason you want to do this is, so let's say you have this water with a bunch of mixed particles and you only have coarse filtration. Now this wouldn't work very well because the coarse particles will get stuck in your mechanical filtration, but all the medium and small will get through. Now that's pretty obvious, right? But what a lot of people instead try to do is they try to do this, where they only have very fine mechanical filtration, and this doesn't work as well as layering, because what happens here is basically the small particles all get trapped within the mechanical filtration, but the large particles and the medium particles, they get stuck outside. So they get all stuck outside here and they are not able to enter. So in the end, you get, well, clean water. So it works, right? But the problem is, this will be much higher maintenance, because you're not utilizing this full space you have to filter out all your solids. Instead, the large stuff is getting stuck out here, and this will clog your filter fast. So if you have a setup like this where you only have very fine mechanical filtration, just one kind, that just means you'll need to have a filter that is maintained at much more intensely. You would need to clean out this filter a lot more often to get rid of this gunk that is blocking your filter. The ideal way to do it is to have it in a variety of layers. So basically you start off with a coarse layer, so the big stuff gets stuck here, and then a medium layer where the medium particles get stuck, and then you end with a fine layer so it catches all the fine particles, and then you end up with clean water. So the end result is the same, but this setup will allow for a much less maintenance filter. So this is what you want to do ideally, but even if you do this, it will work. You just have to clean it more often. And people confuse this a lot. So you want to go from coarse to medium to fine. Okay, so now let's discuss biological and chemical filtration. So biological and chemical filtration is basically getting rid of dissolved toxins that are in your water that are usually directly responsible for killing your fish. So basically, let's say this is a chemical toxin here that is dissolved in the water. It's very nasty. And biological filtration utilizes beneficial bacteria, and the bacteria will convert the toxin into something that is harmless. That is what biological filtration does. Chemical filtration, on the other hand, you add these chemicals that, through a variety of mechanisms, break down the toxin into something that is harmless. That is what chemical filtration does. And another thing that is often categorized as chemical filtration is something that is activated charcoal. So this is just basically burnt wood. It's charcoal, and what charcoal is, it's sticky in a chemical sense. It's not sticky to your touch, it's sticky to chemicals. So anything that is in the water, usually it will get stuck within these tiny pores that are in the charcoal. So they'll get stuck like this, and because they are no longer in the water and they are sticking to the charcoal will be able to remove the toxins from the water. Now, in terms of getting rid of dissolved toxins, this chemical aspect of things is not really relevant to the hobby, because as you can see, these chemicals you have to constantly add to make that chemical filtration happen, and this activated charcoal, eventually all these pores will get filled up, and then this charcoal isn't going to work anymore. So these are not a permanent solution, whereas biological filtration is. So for industrial like wastewater treatment, chemical treatment is a relevant thing, but for a hobbyist perspective, biological is definitely the way to go. So for biological filtration and dissolved toxins that you're getting rid of, basically the most important concept that you have to understand is the nitrogen cycle. There are a lot of different types of toxins that are dissolved in the water, but by far the most important one is nitrogen, and the product that is ammonia. So this is ammonia. And ammonia, where it comes from, is it comes from proteins. Remember how I discussed that the food you're adding to the water is the source of the pollution? Well, that food is going to contain protein. And once that protein goes through your fish and bacteria and any other organism really, this protein will be converted as a waste product, which is ammonia. So this ammonia has a pretty high toxicity, relatively speaking. And you need bacteria to lower the toxicity of this ammonia. And the first step is done by Nitrosomonas. And this bacteria basically converts the ammonia into nitrite, NO2. And NO2 has a relatively medium toxicity. And then the next step is to convert it to nitrate. And this was previously thought to be done by Nitrobacter, but actually turns out it's mostly Nitrospira. So this is the final product, which is nitrate, and this has a pretty low toxicity. So basically, biological filtration is turning stuff that is highly toxic into stuff that is not so toxic. So that is the nitrogen cycle. So you end up with the end product of nitrate. And a lot of people understand like how ammonia is converted into nitrate eventually, but people really don't understand why that is. What is the bacteria actually doing? So what they're doing is basically eating the ammonia. So for humans, Humans say they're eating a slice of pizza. The food goes in the form of carbon. Most of the energy that we derive is in the form of carbon. And we breathe oxygen, O2, and this oxygen and carbon is combined, and we use this to power our metabolism. So we get energy, and some is lost as heat. And this carbon ends up as CO2. So that is what humans do. What stuff like nitrous ammonius and nitrospira do is instead of carbon, they eat nitrogen stuff. Stuff like ammonia. So they eat this ammonia. They also, like humans, breathe in oxygen. And they use this oxygen to basically burn this nitrogen fuel that they're eating. And they use this to get their energy, and some is lost as heat. And they use this energy, and then their waste product, instead of CO2 like humans, is NO2. And the same thing happens here. Different types of bacteria, namely nitrospira, will eat this nitrite, and then they'll breathe in oxygen, and they will release nitrates as a waste product. So that's what's going on. Basically, ammonia and nitrite is food for these nitrifying bacteria. That's what they're doing. So we get this problem with this cycle is, although nitrate is low toxicity, I said low toxicity, not no toxicity. So basically in your water, your nitrate levels will slowly climb up. Will slowly go up, and eventually it's going to reach a threshold where it's going to kill your fish. And some fish are very sensitive to nitrates, and some fish are very hardy and they can tolerate very high levels of nitrates. But eventually it's going to get to that point. And what you do is you do a water change at that point. This is why water changes become necessary, because in conventional filtration, you're going to end up with nitrates building up, and the only way to get rid of it is to get rid of the water. So initially you start off with some scary ammonia here, and then through biological filtration gets converted to happy, non-toxic, well, not low toxic nitrates. But eventually these guys are going to keep building up, and the only way to get rid of them is to remove the water itself, so you have lowered nitrate concentrations. So you do water change, you drop the nitrate concentration, and then it can slowly build up again. Then you do another water change, and you keep it within a certain range, so it doesn't build up and kill your fish. So that is why water changes are necessary. So if you want lots of biological filtration, you're going to need a compartment where these bacteria can grow. So there are several different types of biological media. There's stuff like bioballs. These are synthetic media with a lot of pores, you can see. A lot of surfaces for the bacteria to grow. So basically the key to biological media is surface area. Bacteria, they grow on the surface instead of just floating around in the water. They need a point to anchor to. So let's say you have something like this with not so much surface area. You're not going to be able to grow that much bacteria. But if you have something with high surface area, there's all these spaces for the bacteria to grow. So biological media is all about having something that is high surface area. So you can use stuff like this, bioballs. And actually, stuff that is commonly used for mechanical filtration like sponges, they also have tons of tiny pores for bacteria to grow in. So sponges work great. And then there are other types of biological media like this. These are basically baked ceramic. If you look closely, there are tiny pores on it. So this stuff is also commonly used as biological filtration. And really anything with a large surface area can work. So you can even use stuff, commonly used stuff is sand and fine gravel. Anything with a large surface area basically works as biological filtration. That brings me to my next point, which is mechanical media and biological media. What's the freaking difference? And really, the answer is there isn't. So stuff like sponges, I introduced them in the mechanical filtration section, but as I just said, they can be also used as biological filtration because this has small pores that doesn't let solids through, but also it has these tiny pores that serve as surface area for bacteria to grow. So really there's no real distinction. Stuff like sand, it also has small pores that doesn't let large particles through, but it also provides a large surface area for bacteria to grow. So really there's no distinction between mechanical media and biological media. Like, they can serve both purposes, but the key is which is lower maintenance. So stuff like filter floss and sponges are a lot easier to clean. So the thing about mechanical media is all those pores are going to get clogged up by the solids, and you want to clean it out intermittently to revive those pores. And in order to do that, it should be easy to clean, and filter floss and sponges are much more easier to clean than, say, sand or gravel. So that's where the distinction is it has to be easy to maintain. And basically, you can use any media in whatever way you want. You can use it for mechanical filtration purposes, or you can use the exact same media for biological filtration purposes. It's just that certain media is easier to maintain in a certain configuration. So basically, let's see how you want to layer your filter in the ideal way. So let's say this is filter number 1. This thing is entirely made of a sponge. It's all sponge. Will this work? And the answer is yes. So this initial area will kind of be used up to mechanical filtration as the water is going in this way. And most of this area will colonize beneficial bacteria, and that will do biological filtration for you, and you'll end up with clean water. So it would work. The only downside is because the whole thing is a sponge, it's going to be fairly expensive. Now sponges are not that expensive, but it is a lot cheaper just to have a little bit of sponge and use something like sand or fine gravel here. That would be a much more cost-effective filter. So that's the downside of using all sponge. And this is really the ideal way to layer a filter. You want to have some mechanical and biological filtration. So biological filtration relies on a large surface area, and they have these tiny pores that serve to greatly increase the surface area that is within your filter. And if you have any solids inside there, these solids are going to clog up these spaces, and basically it's going to reduce the effective surface area of your biological media. So you don't want this to happen. So you want a layer of mechanical filtration in front that's going to get rid of the solids, so only clear water is passing through your biological media. So you want to start off with a coarse sponge, something like a coarse media and a fine media to filter out all the solids, and then the clear water you want to get rid of the dissolved toxins by using biological media. This is the ideal and least maintenance, low maintenance way of doing it. Now you can have 100% biological media like this, and it will work fine. As I said with the sponge, this front area will be clogged up with all the solids, so it will serve as a mechanical filter, and the rest will be used as a biological media as it was intended to. The only downside is stuff like sand and gravel is a lot harder to clean, as I've mentioned. So this will be a much more high maintenance filter. So basically, all three of these will work. They will work just fine. It's just that having a configuration like this will be the easiest to maintain. So that is how you want to layer a filter, but even if you do something like this, that doesn't mean it won't work. Okay? Okay, so that brings me to my final point. So basically, the source of your pollution is your fish food, and your fish food is going to end up as some solids or dissolved toxins. And the way to get rid of your solids is through mechanical filtration. And the key to mechanical filtration is to have small pores, so it lets water through, but not the solids. And the key to biological filtration is to have a large surface area that can colonize large numbers of bacteria that can process your dissolved toxins into something that is substantially less toxic. And the ideal way to layer your filters is starting with coarse mechanical, and then to fine mechanical, and and then ending up with biological filtration to get clean water coming out of the end. You don't want it going the other way, you want it water flowing this way. So that is the end of this part 2. In part 3, I'll be discussing some other topics relating to basic filtration. Thanks for watching, guys.